Hello, and welcome to the National Academy of Engineering's forum on how artificial intelligence is reshaping engineering education and practice. My name is Sujay Liu, and I serve as president of the NAE. In recent years, AI has moved from the realm of research labs into our daily lives, transforming the way people learn and work. It will no doubt have transformational impact on every sector of industry and society. As these changes unfold, engineers will continue to be at the forefront, designing, applying, and guiding AI in ways that are innovative, ethical, and beneficial. The responsibility to ensure that this powerful technology benefits humanity rests largely on the shoulders of the engineering community. We are privileged today to hear from leading voices in academia, industry, and policy about AI's transformative impact on engineering. The goal is to provide insights into AI-driven shifts in engineering education, workforce development, and practice, as well as to learn about the technology's promises and perils. We have an exciting agenda today, so without further ado, I'd like to introduce our forum co-chair, Dr. Marian Croak, Vice President of Engineering at Google, who will offer some opening remarks. Marian was an undergraduate at Princeton University before she went on to earn her PhD in quantitative analysis and psychology from the University of Southern California. She is a prolific innovator who has accumulated more than 200 US patents, including for the voice over internet protocol that allows us to make voice calls using an internet connection instead of a regular phone line. Please join me in welcoming Dr. Marian Croak.
Thanks to all of you, and thank you for coming and participating. I think it is going to be truly exciting. For those of you who are involved in AI, you can already see, the immense potential that it has to solve some of the world's most challenging problems. And then you can also see that it can also exacerbate, other problems that we have in society. But it's a force of nature. It's coming. I don't think we can or want to stop it. We just want to guide it into a way that there's more positivity there than anything that portrays itself in a negative way towards a person or society or, in any state whatsoever. So I'm really excited about the participants that we have here today. They're going to talk about the intersection of AI and engineering, terms of how it affects the workforce, how we should think about it. There's going to be a fascinating discussion on how we can use AI to collaborate creatively in terms of music and the arts, and then we'll have an open panel discussion that we hope all of you will provide. Or that we as a panel will, provoke interesting conversation among all of us. So with that, I'd like to thank my fellow panelists and the keynote speakers that we have. Megan, who I'm sure most of you know, will introduce herself, but we also have others participating. Lisa will be our moderator. We'll have Julio give a really interesting talk on what he's doing in his research realm, and we'll have others participating as well. And with that, I don't want to take up too much time, but I did want to make sure that I acknowledged all the people behind the scenes that have been such a big part of this production and have truly helped us a lot in getting things prepared. So with that, I'm going to turn it over. We had a little change in format, so I'm not quite sure who I'm turning it over to. Let's see. Giannis, I also wanted to recognize you. I'm sorry that I didn't. He's dean of my former beloved both college experience and graduate school experience at USC, which is a tremendous university, and we're lucky to have him participating with us. we had unfortunately a cancellation by Charles Isbell, who's now the chancellor of the University of Illinois, and he can't make it. So I need someone to step in as the first speaker. And I guess, Giannis, would you be willing to do that?
I believe so.
Thank you. I appreciate that.
Of course. Um, Good morning or good afternoon, everyone. I'm Yanis Yortsos. I'm the Dean of Engineering at USA. I'll show and share my slides. I will talk about, obviously, AI and higher education, higher engineering education rather than higher education, although a lot of the things that I will discuss do approach or touch upon higher education as well. Education in general, actually, given the fact that AI is penetrating so many things. It's very interesting that we're living in an era in which what I say today, maybe half an hour later, will not be valid or they will be different. As I was putting together my slides, I realized that I would have to sort of change them pretty much every other day, given the fact that, AI is moving so very fast. And so that I don't disappoint some of you, I do have an equation for that. And so I can show you why, why this, I think, is the reason. So let me share my slides. So I'm going to go share my screen. Just one moment. Everything good. Okay. So again, welcome to all of you on this very interesting forum. It's kind of interesting that as I look around at our panel, two of the main speakers are actually chemical engineers. So I don't know exactly why chemical engineers were selected for this. I suppose it's because a lot of the things that are happening have to do with the fact that we are essentially seeing a transformation, something that is actually more than simply, as I mentioned, will mention later, an inflection point. I think this is sort of a phase transition in many ways, and I think maybe that's one of the reasons that we go here. So let me go to my next slide. And so what are the relevant questions that one can discuss with respect to higher education and AI? So I'll just go through 2, 4, 5 of them. So what will or should engineering be like in the years to come? That's an interesting question. Will it be a reflection of the engineering of today, or it will be fundamentally different? Third question is, more importantly, can the engineering profession play a role to shape its own future in this upcoming AI tsunami or wave? There's a fourth item. Can a future be created where engineering has a broadly recognized image that celebrates the roles that engineering engineers play to address societal and technical challenges? And finally, how can engineers best be educated to be leaders, able to balance the gain afforded by these technologies with the vulnerabilities created by their products without compromising the well-being of society and humanity? You would agree with me that these are important questions, and these are questions that perhaps we will need to address as we move forward in this conversation as well as later as well. The interesting thing, though, is that all these were addressed before, and these were the questions that were addressed by the engineer of 2020. The National Academy of Engineering in 2004 published a report called Visions of Engineering in the New Century. And the questions that I saw here, that I presented here, are precisely taken from the questions that were asked there. So it's kind of interesting that 21 years later, we're addressing kind of the similar questions, but for a very different technology. And this technology obviously is AI. I remember when I started as a dean about that time in engineering, that the first text that I read was The Engineer of 2020, trying to understand how the community look at how the engineering is going to change. And in fact, many things changed since 2004. That report was followed later on with a different report, which is the Educating the Engineer of 2020. The National Academy came up with that particular report in Adapting Engineering Education to the New Century. It was published in 2005 and outlined a number of skills that engineering graduates should have by 2020. What were these skills? Analytical skills, practical ingenuity, creativity. This has actually shaped the way we taught engineering in the last 2 decades and more. Communication and teamwork skills, business and management skills, things that are important on how we practice engineering, high ethical standards, professionalism, leadership, including the combination of policy and technology, flexibility, resilience, and lifelong learners. So one of the questions that we will need to address as in higher education, as well as in the profession in general, is these attributes of the engineer of 2020, which, by the way, graduated 5 years ago, are still the specific items that we have to have for the future. Whether AI is introducing different additional attributes that we have to include in how we address the profession and how we move this forward. Obviously, a number of them, or even actually pretty much all of them that you see here, will continue. The question is, what are the additions that we have to have? What are the specific attributes of the engineer of 2020? I will make a case about what should be the attributes of how do we use AI in higher education today, higher engineering education today, and what should be the attributes of our students upon graduation in a new era, which is obviously, we'll not call it the engineer of 2020. We have to find out a different way of describing what this new era is going to be. I think I will not be surprised if the National Academy comes to the conclusion that we have to actually come up with similar type of reports, perhaps in the foreseeable future, in order to be able to guide or advise how we move forward in this very, very important and different era. So I very much would like also to bring into the picture the late Chuck Vest, president of the National Academy, who passed away in 2013, but who also called the period of time that we essentially traversed from 2005 to approximately today. He called it the most exciting era for science and engineering in human history. And I believe that this era is pretty much the same today. It's equally exciting for science and engineering. And should they be the engineer of, they call it the engineer of the age of intelligence. This era is by Tom Friedman, recently called it the age of intelligence. I'm not sure that this is something that will last for the foreseeable future, but definitely it's very apt at this point to call this is the era that we're entering. And so the question is, should the engineer, what should be the engineer of the age of intelligence, and how is to be educated? So I'll try to touch upon some of these items, and then I'm sure that when I wake up tomorrow, I'll probably see something new that that was not included in today's presentation. So with anticipation of the fact that things are changing very, very fast. As I move forward, the first question I think we need to answer is the following. What will remain constant in engineering and as well as many other disciplines as well? So here's my view of this. And first of all, my view is that engineering is fundamentally about purpose, is about solving problems. And so this is what drives everything that we do. We pursue this constantly and relentlessly for the benefit of humanity. And I like to identify the 4 buckets which I think we deal with when we talk about engineering. One big bucket is what I call sustainable prosperity. Now, traditionally, this bucket is called sustainability. I believe that we use the wrong term for this particular area of work. And if I can have half a minute, I can tell you why. Back in 2023, I was in Greece in the summer, and people asked me to give a seminar on sustainability education. I told people, well, I'm not really an expert in this area. Nonetheless, I gave a seminar, and the Greek term that I tried to use is a translation of the word sustainability into Greek. That translation is viosimotis, which means viability. Yet, the majority of my colleagues in Greece, when they talk about sustainability, they use a different word called aiphoria, which means forever green. And if you translate aiphoria into English, the word is sustainability. My proposition here, which is kind of separate to what I'm talking about in general, but I wanted to mention it, is that we should use the term sustainable prosperity rather than simply sustainability. Sustainable prosperity provides a positive view of the world in the future. And it's not simply viability, but rather be able for the world to benefit from a prosperity that can actually be continuous for the future. So this big bucket of sustainable prosperity includes energy, water, climate, food, materials, everything that we associate typically with sustainability, but with a different view, the different lens of being in a prosperity way. A big bucket is health. Bioengineering, biochemical engineering, these are things that we do in engineering. A third big bucket is security. This includes cybersecurity, space, national security to a large extent, infrastructure, electronics, supply chains. And a fourth big bucket is enriching life. That's arts, education, entertainment, enabling scientific and technological discovery. All of them have an engineering impact on society. This, I claim, will remain constant for the foreseeable future. And this is actually what we do in engineering. As humans, we would like to have sustainable prosperity, advanced health, advanced security, and advanced enriching life. And that demand, this effort demands a deep technical domain knowledge. Now, I have when the National Academy of Engineering articulated the grand challenges in 2008, there was a similar view of this. And in fact, people mention that potentially all these things can be viewed as a Maslow hierarchy for humanity. We all know about Maslow hierarchy for individual, but let's map all these buckets into a Maslow hierarchy for humanity. So these are sustainable prosperity, security, health, and enriching life. So I believe and I think that this will continue being the driving force for the future, regardless of the technology that we develop, whether it's AI or something else. And this will continue to drive and motivate all of us in engineering, as well as many other disciplines, the sciences and others, in order to be able to live in a world worth living, which has all these elements from sustainable prosperity all the way to enriching life. So this remains constant. The question is, what changes? What accelerates is advanced computing. And AI, including also quantum computing, which is not part of AI per se, but actually is part of a significant part of advanced computing. We are experiencing a transformative moment. It is more than exponential and is closer to a singularity. So I have here a little bit of a plot that shows the data point that's used to train things, and as a function of time, this is actually obsolete because not obsolete, it's not updated. But you can see that this is on a logarithmic scale, semi-logarithmic scale, and you can see the tremendous increase by which things move, and this almost approaches a singularity. And actually, I have as I mentioned, I have two equations that I will show in this respect. Let's assume that if innovation follows a first-order reaction, let's say it's autocatalytic, then the rate of change of innovation will be proportional to the state of innovation, if you wish. That gives you an exponential. That exponential, let's very, very liberally call it Moore's law, because Moore's law, clearly, it's an exponential. Yet, if we allow that the rate of change of innovation involves what in chemistry we'll call a second-order reaction, then the rate of change is faster than that. And if the exponent is higher than 1, it's in this here 2, then the solution of this problem gives you a singularity. And Kurzweil actually mentioned way back the singularity. He wrote a book called The Singularity is Near. Of course, the question how near it is has always been moving, but nonetheless, you can obtain a solution that looks like this. So understanding, understanding how this moves is a very important part of our for our students to understand, have a deep technical knowledge of AI, whether it is machine learning or neural networks, are very, very important because it is necessary for us to understand the reason why this technology moves so fast, whether you are in a major which is chemical engineering or computer science or electrical engineering, and trying to understand exactly what it means with respect to the impact that it has in our education as well. So I will summarize in this thing here by saying that generative AI provides seemingly intelligent answers. And when we go actually to robotics as well as embodied AI, that actually is bigger than simply providing answers, creates seemingly remarkable new concepts and delivers replies and new constructs at unprecedented speeds and scale. And in fact, he steered a lot of debate on cognition. There's a lot of questions about, what exactly is the connection of AI to cognition, understanding, and potentially consciousness as well. And these are obviously big, important areas. I know that there are very strong positions from different people about whether this is possible or not. I think this is an element of research, and I think we'll be able to understand this more and more as we move forward. What I wanted to mention, though, is that AI is both a tool and it is a technology. And so I like to make this distinction a little bit at this point, because as a tool, it can be used to help us in terms of education and teaching. And as a technology, it can help us in terms of what we do in engineering education towards research. And so the implication that AI will have for education and the practice of professions will be profound. And I think we've already seen this in many different ways, certainly with respect to the speed by which this is happening. So let me go to my next slide. And I would like to sort of close this part of what I'm discussing here by making a symbolic equation. I mentioned that I will describe some equations, but this here provides us a symbolic equation. The constant purpose of engineering and the fast accelerating technology leads to this intertwining of technology with society. So here's my symbolic equation. You put together a triangle, which is the Maslow hierarchy for humanity. You add to this a hyperbola, which is the AI as a function of time, potentially a singularity. And what you get out of mixing of these two is a double helix. And what is this double helix? Is a double helix of technology with humanity. So even though this is sort of a tongue-in-cheek type of equation, I do believe that this is the world that we're in today. It's a world where we have to use technology that goes extremely fast in order to be able to solve important problems that are in this Maslow hierarchy definition. And this introduces this very tight coupling of technology with society and humanity, a coupling that we have never seen before, not only because it is very tight, but because it also moves faster and faster every day. And actually, most of the conversation that we have today is what exactly is going on in this coupling and how do we make sure that we use it correctly for the benefit of humanity and the benefit of the world at large. So I call this the symbolic equation of our multi-hyphenated times. And that demands trustworthiness, because it is not about technical competence, which perhaps comes from technology, but it also comes from character, outstanding character, which comes from what we need to do for advancing humanity's goals towards enriching life and many other things. And essentially, it provides the quintessential human in the loop that we talk about all the time when we talk about AI. So to me, The new element that is coming in with this very significant and highly advanced technology, fast-moving technology like AI, is trustworthiness. To combine both competence, outstanding competence, and outstanding character. This outstanding character has to be both with us in our engineering students, as well as potentially in the sort of what people call trustworthy AI, or things that can actually be embedded into the way by which AI is used for or developed for many in many areas as well. So I hope that I can sort of symbolically represent what I think are the key elements of the interaction of AI with engineering and technology as well. So let's look at AI as a tool. And so I will make, again, I don't know, I am a chemical engineer, so I talk a lot about chemical reactions. And so I look at learning as a transformation, potentially as a chemical reaction. It's an endothermic chemical reaction. Endothermic meaning that one has to put energy in order to be able to get it going, because that's what learning is about. And if you look at Bloom's taxonomy, it's all about how you acquire knowledge, how you understand it, you apply it, analyze it, a lot of steps. I simplify this in a very rude way in terms of one equation. And this equation says, if you take faculty and students together, then in an education context, you create a product which enlightens both the faculty, so I call this F star, and the students, I call this S star, because that's how people learn. Again, I know, and I apologize that this is such a simplistic thing, but I put it in here in order to indicate that for me, AI as a tool can be used as a catalyst, or as a catalyzing teaching assistant and a mentor in education. This is already been happening in many universities and in many classes across the world. How? Because people always have to be able to handle the fact that students have access to things like ChatGPT and so on and so forth. So the question is how these AI tools, these AI mentoring tools, can be used in order to be able to facilitate and improve learning. So in all this, my definition, individual courses are the chemical reactors where such reactions occur, and AI is the catalyst that accelerates the reaction. So to show you what I mean from a perspective of energy, I have another plot here in which I plot learning in this moving up in this direction. This is the content of learning, the amount of learning that happens. This is the course extent. We want to go for a student from this point of knowledge all the way to a higher point of higher outcome. And this essentially reflects what we call in general critical thinking, because the more amount of knowledge we provide to our students, the better the students will be in order to be able to apply critical thinking. And there is this activation energy barrier. This is to go from the beginning to the end. And my sort of a proposition is that AI will be as a catalyzing assistant that make this activation energy lower and enhances critical thinking without supplanting it. So it's kind of a learning companion and a coach. The question is, how do we make sure that this is done in a way that, in fact, benefits the moving along this chemical reaction and essentially accelerates or makes learning possible. So this is how I look at AI as a tool in a classroom. And I believe this demands also faculty expertise that is superior to this specific TA, which in this case is AI. So that's actually something that we want to make sure that our faculty, as they teach, they do not delegate the teaching part to an AI, because in this particular case, obviously, it is almost like their skills and goals and attributes become obsolete. And I think we have to look at the AI in the classroom, and in this case, as sort of a catalyzing teaching assistant mentor. There are quite a bit of interesting things that are happening, including at my own university, on how one can develop these tools that help advance this knowledge and this critical thinking and advance this Bloom taxonomy without sacrificing the learning process and without making with making sure that our students understand that the important point is not for them to provide answers, but actually to be able to provide answers that can be defended the same way that we defend, for instance, PhD thesis after we write them. And there has been a sort of a proposal, some proposals out there that perhaps the way we evaluate students and students' performance would be akin to the way we evaluate PhD thesis, in which there's a lot more critical thinking and critical questions. And of course, if that is the case, that will change dramatically the way classes are taught and so on and so forth. Now, I want to also mention that technology, I look at AI as a technology. So before I go there, I want to ask the question, what is technology? And I use this very simple definition, which is leveraging phenomena for useful purposes. Now, phenomena can also be systems, devices, and tools. And useful purposes can also be including discovery of new phenomena. So this is paraphrased and extended from a book that Brian Arthur wrote in 2008 called The Nature of Technology. And the phenomena that we use in engineering are physical, chemical, biological, and I contend that increasingly so social and behavioral. And these bring up many interesting items, technology, like ethical and moral, unintended consequences, complexity, and policy issues as well. I think this is what we do without having, let's say, technologies like AI, and we have been doing this for many decades, centuries perhaps. How do we leverage this phenomena to obtain useful purposes? By the way, because I like this definition more than any for technology, because the useful purpose item introduces sort of a moral item to it, because what's useful to someone is not useful to somebody else. And so it is, again, the concept that technology is about and engineering is about purpose. And so useful purpose, I think, provides some sort of an ethical or moral element that actually will become more and more important with AI. So you ask yourself the question, well, what about AI? Why would you say that AI is a technology? I say this because AI does exactly that, except that instead of leveraging phenomena, it leverages data. And so that's the fundamental difference, I think, between the things that we have been using in the past, in which we use differential equations, calculus, things that was a Newtonian approach to looking at the world, to now going in a different way, in which we use AI as leveraging data for useful purposes. And this is happening every day. People use, so research is very much influenced now significantly by AI in many different ways, particularly when you are to solve complex problems that somehow the traditional approach by which we follow may not be enough. A classical example of this is the wildfires in Los Angeles that happened in January. I know a number of my colleagues, after the fact, of course, use models that rely very much on AI in order to be able to make predictions about where the evolution of the fire front, and how it can be used to support the firefighting exercise as well. Now, there are other items here as well. People like Friedman talk about a super intelligent machine. It's too bad that Charles, the speaker that was supposed to be here later on, is not here today to tell us to share his opinions, because he was talking about humans and machines. These obviously are things that are very much in the making. Where we're going to go with this is obviously at this point an open question. So these are my concluding remarks that in the intertwining of technology with humanity, engineering graduates will be the quintessential human in the loop. In other words, we have to make sure that we prepare engineering graduates to be the ones that are able to have three attributes: a specific domain knowledge, which is essentially the specific domain knowledge that we provide to them today, whether you are in, let's say, mechanical engineering or civil or outside wells, other places as well. I'm sorry for my timer here. A thorough knowledge of all the AI technologies, because it is important for all of our students to understand what drives AI, what it means, the fact that, that there are, the machine learning and neural networks and everything that's associated with that, and to have an outstanding character. So to me, these are three important attributes that will become, I hope, the goal of every engineering school, to provide graduates that have maintained their specific domain knowledge, they have a thorough knowledge of all AI technologies, and also they have an outstanding character, so they can play the important role of the human in the loop, because it's the most important part as we move on forward. This calls for incorporating AI in the curriculum and research in the ways that render it helpful, honest, and harmless. This has been said before by others. I forget who is the author of this specific three-way description here, but I find it to be very, very useful, because AI has to be helpful, has to be honest, meaning understanding that the origin of it and where it comes, and harmless. Finally, it suggests to add to the engineer of the age of intelligence, or the new engineer of 2020, if you wish, a new attribute: purpose and character, in addition to technical competence, that therefore lead into trustworthiness. It's something that I have been pushing or advocating for a while now, and before AI has reached the point that it is today. I think if we need to make sure we create people with trustworthiness, and this is not simply technical competence, but also purpose and character. And so this adds trust to three elements of energy, materials, and information. I'll make a little comment here. When I first started as an assistant professor, the then chair of the department at USC in chemical engineering, Joe Goddard, who I think who is an emeritus professor at UC San Diego, told me that engineering is about three things: energy, materials, and information. It is fascinating. By the way, I said to him, well, of course, I'm in energy, so I'm in good shape. But it's fascinating to see that today AI is actually encapsulates all three of them: energy, materials, energy centers, data centers. We know how important that is. Materials in terms of chips, and information in terms of how you manipulate information and move information around neural networks and the like. However, what I think we need to add to this now and in the future, we have to add trust to all of these things here. And I think this is something that is an important part. I suggest that it's an important part of what we need to do as we move the new engineer in this new age of intelligence, because this human in the loop sort of a statement about the role of humans in this very tight intertwining of technology and humanity is very important. I will close by example of some offerings that we do at USC. We have a new School of Advanced Computing. This is a human-centric oriented. We require all engineering majors to be exposed to AI and machine learning, understanding all of the significant parts, both at the hardware and the software part. We have a new AI degree in computer science and a joint degree with business, and a Center for Gen AI in Society. There's a lot of work that is done there in terms of understanding the role of AI as a TA that I mentioned. We have an Institute for Ethics of AI, and there is many other things as well for reflection, for AI, for brainstorming and editing. I'm sure these are things that many other places have as well. And I think I'm almost certain that these are going to be spreading faster and faster in the foreseeable future. Some acknowledgements to some colleagues that helped me put together my thoughts on this. And I wanted to close here. I have some other thinkings about pros and cons of AI and how it is used and the impact it has on society. But I think Megan and Julio are going to discuss this in greater detail. So this is the end of my presentation. Thank you for listening, and I'll just stop sharing.
Thanks, Giannis. I think I'm up next. I don't know if we're doing anything particular, but I can share my screen for everybody. Giannis, that was wonderful. And I think I really resonate with when you started with sustainability. I always think about sustainable abundance or how we can thrive. Quickly bring up a screen. Hello, everybody. My name is Megan Smith. I am the CEO of Shift7, and I also served as the Chief Technology Officer for the United States and Assistant President with President Obama. I have a background in mechanical engineering from MIT, and I did my master's in the Media Lab on haptics in that area, and then ended up working in Japan and then in Silicon Valley for about 30 years at Google and on smartphones and lots of different things. So that's kind of some background. What I'm going to focus in on is Giannis, thank you for that focus on the engineering learning, so education, focusing on practice. And I have a specific area, which is this concept of widening the aperture, because if we can use AI for the kind of future, we can probably really broaden participation in ways that are really compelling for all of us. So I put these a couple images, but the main images I wanted to focus on first is, of course, the live long and prosper, that future. Van Jones sometimes calls it the Jetson future. Then there's also the 2001 when HAL kind of comes in, and we see a very different future for humanity, which kind of a Terminator future, as Van Jones calls it. I grew up with a love of Star Trek, and in fact, in our neighborhood as a child, we played Star Trek, and every single kid in our whole big group grew up to be the character they played. I, of course, played Scotty, so I'm an engineer. But how important imagery is and what we see in the future. And what I think about Star Trek is really this place where we are exploring together, going together into a future where the computer is assisting us and helping us. And it's highly dynamic, integrated team that has different skills that are played out. And the computer continues to assist, whether it's in the journey or whether it's in information or whether it's medical and across the board. And that's the hopeful future that we want. I'll come back to some of the other images on the screen later in the presentation. But what I want to do today is I'm going to go through very rapidly a lot of images, and I'm not trying to go deep on any of them. I know that I think around 1:15 we'll have a break, so we'll finish before 1 for Eastern time. But the question is, can we dramatically expand who is an engineer leveraging these technologies? Who gets to be at the design side of the table? And of course, we're seeing a massive impact on every single engineering discipline. We'll get into that. But really, my thought is, how do we use some practices to figure out how to expand the topics that are worthy of engineering? A lot of times we saw, certainly for me, going from Silicon Valley into government, I saw that there were certain places where, as a technical person, people expected me, maybe in the precision medicine meeting, but they didn't expect me per se in the foster care meeting. But now that we think about that, wouldn't we want AI support for those systems to help our most vulnerable children just as much as we would want AI in health and engineering and technology? So how do we kind of play the whole orchestra on all the problems? So I'm going to go through a lot of slides, and I'm going to get to 6 methodologies, and I'm going to share examples of those methodologies, which I think can really help us dramatically expand participation in this AI future. The first image, I just want to celebrate where we are. At the end of the administration, we had a Frontiers conference, and we just looked at where we are in terms of these frontiers, and think about just today, the personal frontiers, personalized medicine, personalized learning, the opportunities we have with AI and all of technology and the internet itself, our connectivity with other people in humanity, and resources for yourself. On the local side, the idea of smart cities, the idea of much more sustainable capabilities with our communities, interconnecting communities, and the opportunities there. On the national side, we looked at really artificial intelligence, and I'll share a report that we launched. Globally, of course, the environment is of great concern. We need to figure out how to reduce our polluting ourselves with plastics and toxins. How do we create that kind of thriving nature? You know, we are nature, we are part of nature. And I was with Sylvia Earle at National Geographic yesterday. Certainly the ocean sustains us. How do we make sure that we're taking care of our planet and ourselves, really? Because as we take care of the ocean, we take care of humanity. And then interplanetary, you know, we are now about to send in the spring another group to the moon, as we are both doing near space and far space. So this conference was really exciting. It brought together people from across the United States working on these things. And obviously this is a US frame, but of course, globally, all of this is happening too. At that conference, we released the first reports on artificial intelligence for the country. It was 2016. And the only reason to highlight this is I want to return back to the bottom corner there on the left, that we did open town halls. And I want to really encourage us to think about being more participatory in how we open up this space, opening up conversations. These were open meetings for anyone in the public to come, very similar to the briefings that took place for George Bush in the late 90s, open calls with Newt Gingrich, Kara Swisher, and the teams from Netscape, Jim Barksdale, who went all around the country talking about the networks. So we did that with AI. Just to touch on this idea of our own industries, I actually just prompted ChatGPT with a really simple prompt, like, what is it like before and what is it like now? And it was interesting to see some of these are hallucinations, but most of them are there. Certainly, we would agree that down at the bottom, learning, we want to keep the textbooks, lectures, hands-on apprentice together with the AI simulations. But really, it's this optimization of capabilities that's coming across every aspect. It's affecting every part of engineering. And there's opportunities here to leverage the things on the right as well as on the left of this chart for everyone. And really, for the first time, some of these tools are becoming available to anyone, even if they don't have an engineering degree. So we can pull those people in. I also just want to point out human intelligence at the front. If you have grandchildren, children, nieces, and nephews, you certainly know about Moana. This is a real life Moana. This is the Hokulea team. They sailed around the world with no instruments. So the fact that, you know, a small group of humans, maybe a dozen, could be on one of these canoes in the middle of the Pacific and still go that way and know what they are doing is extraordinary. And so is it intelligence? Is it wisdom? Is it the ability for us to really expand ourselves? That feels like the real goal, and to have these technologies come in and help us, as opposed to some kind of future where we're led by robots and it's not really a shared future. My favorite thing that happened after the voyage was a grand challenge that was launched for all the young people of Hawaii to clean up the Alawai Canal in Waikiki. Just extraordinary participatory solution making, which gets at the heart of what I'm talking about, of really inclusive, collaborative future that we can have if we can bring more people into the conversation. We hosted in the Rose Garden during astronomy night, our longest standing navigators, and on the left, and on the right, of course, the NASA commercial crew at the time. So I turn my attention to a related component, which is, this is Vannevar Bush's, Dr. Vannevar Bush was FDR's science advisor. He led a lot of the wartime technologies, which are illustrated in the bottom here with radar, of course, many other technologies during the war times. From that, he wrote this presidential report called Science, the Endless Frontier. Many people are aware of this report. It talks about really fueling the research universities and fueling all of our academic institutions to really push the front of science like we did during the war. We learned how to do that. And the essay here, The Job the Lad Did, on the right-hand side, really speaks to what happened because we opened up this freedom and fuel finances from government funds to allow people to invent, in this case, in the purpose of defense and military technology. But then this key essay is the pivot that founds the National Science Foundation. And creates really the American research enterprise. Venture capital was founded. The modern VC was around this same time. And so we started to build this capability and really train people through graduate school to create this endless frontier. The reason why I bring it up on this topic is because one of the less known things in that essay is this idea of what Vannevar Bush wrote, which is he felt it can be achieved only by releasing the full creative and productive energies of the American people. That means all in. And on the bottom left, you see some of the earlier land-grant universities and later, every state, every place, everywhere, can we pull talent into this and make a collaborative future? So now I'm going to run rapidly through some examples. And I want to say most people are feeling nervous. Most people are noticing that if you haven't watched Cathy O'Neill's TED Talk about weapons of mass destruction, that should be required for all engineers. It shows real challenges with algorithms. Joy Buolamwini's face recognition research for her PhD at MIT. We have real challenges. We see our elected officials getting further apart, our country getting further apart because of algorithmic bias. We see potential harms on the left. I want to share that in 2015, 16, my colleague Lauren Smith published the mitigation strategies. How do we have everybody dive into these mitigation strategies and choose them as problem sets for engineering future? We have a great future that we're looking at for commercial application and for certain locations, but what about other parts of the world and what about other topics? A lot of times we think about some things moving faster than others. This is two places in the desert. They're similar size and similar budget. I don't know if any of them look familiar to you, but you might notice that on the top is a place born of joy. It's Burning Man, and a fun arts festival in Nevada. And the bottom is a Zaatari refugee camp in the northern Jordan border of Syria, people who are there from great suffering. They're really governed quite differently, and yet they exist at the same moment in time. One group is free to collaborate. One group is really sort of more, in almost like a prison feeling. And so what can we do to change the bureaucracies that we have using AI, using innovation, but really using each other? Can we make our systems more kind? When the Apollo mission went, a lot of people don't know, but Ralph Abernathy, the Poor People's Campaign, protested. Of course, they said we're proud Americans, but they also said, if we can achieve this, can't we work on some of the problems here at home as moonshots or earth shots as they were? It's an excellent point. And so what is that inclusive future, and how do we use some methods to do that? And how can we leverage AI in the network that we have? So we wrote an article about, hearkening to Vannevar Bush's Endless Frontiers. Endless talent is the American dream. Can we get everybody in? And these are 6 methods. I'm going to run through them quickly. The first is scout and scale. Make the doers visible. A lot of times, like on the left here, West Virginia's poor man's getting water for his family. There's no WeWork makerspace in that brick building, but he could get in the car and go to Chattanooga, who has the highest speed internet in the Western Hemisphere. How do we share faster? We did a project with the United Nations as the Sustainable Development Goals were launched. We actually social stormed the world asking who is already solving these goals. And we got 800 submissions from 141 countries the first year. The 5th year, we did it 1,400 submissions in 3 weeks from 141 countries. People already solving things. People flying drones to plant a billion trees a year. This is people teaching law in prison to help people with legal representation. There was a floating fab lab, a modern technology space on a boat instead of cut down the trees in the Amazon. And that entrepreneur working across the whole fab lab network and the South American groups, are doing extraordinary things. So already there are people like Bernice in the middle here making bamboo bikes to grow and sequester carbon and create youth and transportation jobs. This is Devura. Thousands of people in Nigeria coming into technology training. So the point is, make the doers visible and help them. The second method is about building communities of practice. We do this a lot at the NAE, but think about the global fab labs. This was started with Neil Gershenfeld, who's an Academy member who does the Center for Bits and Atoms at MIT, talking with Professor Mel King from Urban Planning. Neil said, hey, you should bring your kids from the South End who are kids who are facing less prosperity, and we should bring them to my lab. And Mel said, actually, Neil, you should bring your lab to my kids. And so it started with one, and it has multiplied into thousands of fab labs around the world, and it's a network of talent sharing, and I call it the Wakanda MacGyver community. There's spaces around the country emerging. There's Boise, Idaho is an example where there's 15 tech meetups. And one of them has 800 people in it. So these places, these networks are existing. How do we help more Americans, more people around the world opt into these opportunities for themselves? This is the MIT Solve Indigenous Communities Fellowship, just asking Indigenous leadership who's already solving and who wants to be part of a fellowship. It's now in its 7th year. Amazing innovators from islands, women innovators, people solving already for 10 years now. The DQ Institute has been connecting teachers who already have solutions. So how do you use a community practice like a guild to more rapidly share what already exists from our doers? We did that at the White House by bringing together a tech meetup of all the tech meetup organizers on the right, and then on the left, the people who are already bridging onboarding paths in their community for more Americans to join STEM careers. In this case, we did 2 slides, 2 minutes, and everybody shared rapidly. And we went on an amazing, looking at tech hire. There's more open STEM job. There's more people in prison than open STEM jobs right now. And when you teach tech in prison, you can get 7% or 10% recidivism instead of 70 or 60. So we went on a tech jobs tour. This is Cleveland, this is Silicon Valley, just connecting Americans to the opportunities of neighbors who are already there, a little bit like maybe the Music Man right here in River City. How do you meet your neighbors and start making the economic future that can exist, like George Washington Carver did in his day? The third practice I'd share is networking the disconnected networks, cross-fluency. I was lucky to go to MIT. One of the things that the recent Nobel Prize winner in chemistry said is you can go out of your office and you run into people. I show this image because, of course, sometimes we silo them. We were lucky that the initial buildings at MIT were connected between the arts and technologies and sciences to bring people together. In government, the idea was to rotate as a tech tourist duty, just like in the National Academies on the upper right, with Lincoln adding us, President Washington adding the Army Corps of Engineers. All these digital tech folks now can rotate into government. And we can work on policy. We can work on improving the quality so that websites from governments are just as good as commercial offerings. We can open up APIs so that there can be third-party offerings for many more topics, not just NOAA or US Geological Survey, more commercial areas, but also for health or foster care, et cetera. We can make data maps for, here's the Department of Labor. We can bridge between Safety Summit. On the left, you see more of the commercial leaders and the government leaders. On the right, you see more of the technical people who could collaborate to solve a lot more things together that maybe the commercial people say, yeah, we're working on it, but these people might have solutions we could get to quicker. Another cross-fluency is to notice the technical young people. This is my favorite program in schools. It's a chief science officer elected position. In Pennsylvania, there's 1,200 of them this year. This is a young person like the class president, but they're doing STEM innovation in their crossing into the networks. There's movies coming out, etc. The fourth practice I would share is to sprint, pilot, prototype. We know this in engineering so much, but sometimes colleagues don't use this as much in other sectors. This is something we can bring, and we can use, again, AI fluencies here, begin as a way to begin. Certainly like data paloozas, data jams, hackathons, CodeFest. Let's do that in every different sector. This was a local hackathons that happened, foster care hackathon that we did. We did a police data initiative, hackathons for opening up officer from a shooting, use of force data, other kinds of data sets. All of these jurisdictions are now opening up their data for innovation so we can see what's going on, help each other. This was called Hack the Pay Gap. And lots of economies are suffering because they don't have as much money as they would have, and individuals don't have as much as they would have. So this was data scientists working on apps and solutions for the pay gap. The fifth one I would add is about circulating stories. One of my favorite moments, of course, in the White House is when we do science fair. Every administration is highlighting the talent of America. This is a group of first and kindergartners and first graders, and they've made a page-turning robot. and they're explaining to the president what they did. He asked them, you know, how did you guys make this robot? And they said, well, we had a brainstorm. And then they shared that they built some prototypes. So what if all of us had the opportunity? How different would our lives be if when we were in kindergarten and first grade, we got to wear capes, hang out with our friends, and brainstorm and prototype solutions to real world problems and begin as a way to begin into the practice of engineering? One of the challenges that these young women will face is, and different people, is just bias. This is an amazing data set that some colleagues on the internet made from the pudding.com, looking at who gets to speak in films. Men's lines on the left for 2000 popular films, women's lines in red on the right. And it's, you know, if you look at the children's films, it's pretty extreme. Even Frozen is only 50% girls' lines when we think it's a girl film, or Mulan is 70-something% boys' lines. How do we notice these biases and begin to change them? And how do we also look at history? On my opening slide, I had a picture of Princess Leia. I don't know if you see on the right, similar hair there. This is Ada Lovelace, the person who first thought of algorithms and AI. She said, I think we can figure out the math of the cerebrum if we think about it right, like we did with astronomy, sidereal, you know, star math. And she said, I wish to bequeath to the generations a calculus of the nervous system. She conceptualized the idea of general programmability in an essay that she wrote at the time of Darwin, and she wrote the world's first algorithm. So very important that we share that women and men are the founders in this area, and that some people can have their hair come back in movies years later. This is Alan Turing represented in a movie together with Joan Clark. You know, the Bletchley Park team, here's Kate, the Princess of Wales, who is now talking with friends of her grandmother and great aunt who were code breakers at Bletchley Park. We need to know that in the beginning of computing, it was men and women working together, whether it was ENIAC, Bletchley Park, Grace Hopper, or the Whirlwind. All of this was shared teamwork. Also early on in the second industrial age, topics like Jane Addams working on social work that she won the Nobel Prize for creating, and the Hull House, she did a lot of data science with her colleagues. And so this, to me, is the beginning of thinking of not just a smart city, but a wise community. What's going on and what data could we bring forward? You know, looking at who's been part of things. Ellen Swallow Richards, of course, at MIT with coming up with ecology and beginning to train all kinds of people on reducing toxins. This is Ida B. Wells, who, of course, is a justice data scientist. I bring her up because at the time of Tesla, extraordinary accomplishments at the World's Fair, Ida and Frederick Douglass protested that fair because there were no African-American exhibits allowed. And at the time, they actually outlined in this paper all of the people who would have been seen, which was just extraordinary patent holders and everything. And also on the bottom left, a shout out to Josephine Cochran, who invented the dishwasher and had 9 working full models and won the mechanical prize at the Columbia exhibition. So how do we make sure everybody is seen, that we know Katherine Johnson calculated us to the moon first? I want to shout out Giannis because I'm here. This is Dr. Srinara Tayayan working with Gina Davis and also some with Dr. Stacy Smith and Annenberg, looking at who gets to speak in films. And I love this AI tool where they began to figure out counting of who gets to speak, and maybe helping some of our colleagues with media and bias that we could change in how we work together in making movies, and just noticing, not telling people what to do, not telling our creatives what to do, but having them notice. I've had this experience myself. I worked on the beginning of smartphones with a team that spun out of Apple that worked with Steve Jobs, amazing innovator. And yet this is the team that created the Macintosh, and we don't really see the whole group sometimes. So I want to make sure we got to see it to be it. You know, we want to make sure that, like we played Star Trek, that everyone can see and be that. Okay, very last item is bolstering organizational mechanics, just pragmatic things we can do. This is an idea called raising the floor, which is better sharing what already works for including each other. What can we do algorithmically in AI to notice these practices, and in the community organizing of our large organizations? So this is in an ANAE article from last fall. If anyone wants a bit of an eye chart for a slide, but you can look through it. It's what are the actions you can take in leadership, retention and advancement, hiring pathways, and ecosystem. What is the move? What's the best practice, and how would you measure it to have much broader participation and belonging in teams around your team, your organization, your partnerships, and around the world? So as a summary, really, how can we get in the studio together to co-create? How can we make sure that we're cross-pollinating across ecosystems on things that already exist that we could then scale for solutions to move faster and include each other? And how can we use media to lift up and see the extraordinary opportunities that are here, or the problems or challenges that we might need to collaborate on rapidly? The kind of last two ideas I will leave you with is, I think that it's time for our world, just like the Hippocratic Oath, to take a page from the Canadians. On the right is a bridge that fell down in Quebec, I think maybe around 1907 or around that time. Shortly there, maybe a little bit after, shortly after that, the Canadians came together for the idea of really having a ring that now all engineers are given this ring if they choose to join in this ceremony. And the idea is to really think about the pride of engineering, heroic engineering, and the humility and the responsibility. So what is possible and what is responsible? And how do we make sure that we keep to, similar to our medical colleagues, the kind of best practice that we can have, and the responsibility that didn't happen with this bridge, that the Canadians are there. And I encourage us as the National Academy to consider this. So last slide is just to share something about our own country. In 1792, the very first American penny said liberty, like our coins do today. It was Franklin, Jefferson, and Washington who chose to also include liberty, the parent of science and industry. And so I think we as engineers have an opportunity to think about liberty of all people, and think about how do we really have an age of wisdom, of community, of kindness that goes together with the age of intelligence as we move forward, and how do we make sure the engineering profession leads in this way, and really, again, as I started, widens the aperture for the inclusion of everybody. So thank you so much.
Thank you so much to both of our speakers this morning. We are now going to take a brief 5-minute break. We will return at 1:15 Eastern Time. Thank you so much. Thank you so much. If I can ask for everyone to please return back so we could start our next presentation. Excellent. I will now pass it along to Julio.
Fantastic. Can you hear me okay? Are we okay?
Yeah.
Okay. So I want to thank Wanda and Marian for the opportunity to share my views. I'm taking a wide lens, but with creativity at the center. The wide lens is been making comments about the intersection of art, science, engineering, and AI. And my thesis is straightforward. AI, I will contend, will not replace human creativity, but will become probably our most powerful collaborator yet. And to understand why, we need to look at the history of creative breakthroughs and what they teach us about the future. Now, but before I get into that, I think this slide summarizes the essence of creativity. How something comes out of nothing, really. The best creativity is the one that emerges seemingly out of nowhere. Now, if we want to collaborate, if we want to understand how AI can collaborate across domains, we need to understand how different fields think and create. We normally equate domains with their products. We equate artists with sculptures and paintings. On the other hand, artists equate scientists with, I don't know, discovering something. But at the essence, science is discovery. You can argue that it's making the unfamiliar familiar, as opposed to art, which is making the familiar unfamiliar. Technology is about invention. Art, people outside art will equate art with creation. No artist will use the word creation. They will use words like transforming, revealing, provoking, reflecting, a whole bunch of things. Creation is a byproduct. So these are not different outputs. Mathematics could be creation or invention, creation for the Platonist among us. Engineering is building, invention, design, and kind of cuts across science, technology, and art, really. And the true domain collaboration requires understanding and integrating different thinking modes, not just combining their products. I have humanities in here, but actually what I put in there is more philosophy. And by the way, the words interpretation, questioning, understanding behind philosophy, I didn't come up with that. I had conversations with people in philosophy to see what 3 words will associate with that. So you need to talk with people to see these modes of questioning. Now, today's creative landscape forms a dynamic sort of triangle. Art and technology have a mutual attraction. I think art wants technology's ubiquity and power. Technology, on the other hand, could envy art's untethered thinking and innovation. So the art-science relationship is more one-sided. It's not really reciprocated. Technology serves as a bridge, and this is why many successful collaborations are actually art-technology partnerships. Technology is really the bridge between art and science. Now, before we dive into examples, we need to understand how creativity emerges within a domain. Okay? A domain is all the accumulated knowledge, is what would exist even if humans disappear. Algebraic topology could be a domain, condensed matter physics, fiction, poetry, all the body of work in that thing. The field are the people who practice in the domain, okay? And the distinction between domain and field is useful because it's not enough to have a brilliant idea. That idea must navigate a complex system. The domain is the accumulated knowledge and rules of what could become part of the domain. The field is the human gatekeeping system that decides what gets accepted. For example, in art could be museum directors, curators, critics, collectors, and so on and so forth. And there are different levels of entry. For example, in math, there is no gray zone in there. Either a theorem is proved or not. The domain trumps the field, but in many other ones, the field influences the domain, and the domains can be revised. Now, I want to distinguish between two levels of creativity, okay? A breakthrough is something that they extend what we know. They appear within the domain itself, and if it's something big enough, we'll enlarge the domain. And I put breakthrough, and I should have put a hyphen in there, because in some cases, the breakthrough breaks through the boundary of the domain and enlarges the domain. It makes a bigger domain, okay? A break with, and I want to have this as the upper bound of what is creative, is a different thing. It's a break with is something that is unanchored from all the domain knowledge that form part of the domain, okay? I will get into this more detail, but for example, a break with will be art from representational prior to 1900 in the West to go into abstract, Kandinsky, Cubism, Picasso, Braque. In science, prior to 1900, classical mechanics, thermo, then going into quantum mechanics. In order to have this break with, you needed to abandon assumptions that form part of the previous domain. A good example of this is Edwin Abbott's very nice book, Flatland. It gives us a perfect metaphor. Flatlanders see a visit on a sphere as mysterious. Maybe a point first, but then change its circles, never grasping its true three-dimensional nature. Mastering 2D, you can become the master of 2D, does not lead to 3D. Probably this should remind you of Gödel's incompleteness theorem, that a break with insights requires stepping outside the conceptual framework that generated all previous knowledge in the domain. A system cannot generate its own transcendence. This is what we want to recreate, essentially. The early 20th century saw simultaneous break with across multiple domains. You can pick whatever you want, and you will see a break with. When Einstein and initially Bohr were revolutionized in physics, Picasso was revolutionized in art, literature was abandoning narrative conventions, Marcel Proust, James Joyce, Virginia Woolf created new forms of narrative. In architecture, we have Le Corbusier, modernism emerges, Frank Lloyd Wright, the Bauhaus. In music, we had Stravinsky, Schoenberg, abandoned tonal harmony. And it was this time in which technology was exploding, photography, flight, early cinema. So the question is, what enabled this extraordinary period of simultaneous transformation? Is what we would like to maybe mimic, create today, without creating World War I in the middle of this, okay? So in 1950, Harry Holtzman, who, by the way, was the fellow who brought Pierre Mondrian to the US, had a sort of manifesto, probably one of the first art, science, technology manifestos. And this is what Harry Holtzman said. The name of the journal was, or magazine was Transformation, written in the way that you see there, lowercase with a break. And he said, transformation affirms that art, science, technology are interacting components of the total human enterprise. But that today, they are too often treated as they are cultural isolates and mutually antagonistic. Transformation will cut across the arts and sciences by treating them as a continuum. These are some of the people that Harry Holzman persuaded to be part of this enterprise. You will recognize many, many of the names, from Buckminster Fuller to Heisenberg, Bert Cunningham in ballet, Giacometti in art, Le Corbusier, Einstein, he had something, Pierre Mondrian, of course, Pierre Boulez, and John Cage in music, de Kooning in painting. The experiment lasted 3 years. There you see the entire run of transformation, 1950, 51, 52. They are an amazing thing to have. I own some of these things. You can still get them somewhere. But curating this content that will try to produce this seamless connection between art, technology, and science was amazing. Now, it took 16 years after Holzman's vision, it sort of happened. 9 Evenings was arguably the first large-scale successful art, science, technology collaboration. It involved 10 artists led by Robert Rauschenberg and 13 engineers led by Billy Kluver from Bell Labs. Bell Labs let them free for 10 months, okay? This was not artists getting inspired by science. It was 10 months of working together. They developed entirely new technologies. For example, closed-circuit TV appeared there, infrared cameras, Doppler sonar there. They were co-collaborators. This wasn't science serving art. It was genuine co-creation. Now, this is impressive. Joseph McElhenney, this series of sculptures called An End to Modernity, 2005, encapsulates the Big Bang on expanding universe. It has 20 represent science serving an art here. The scientist in here was a consultant, not a creator. It was inspiration-driven work, which has value, of course, but it's not the kind of collaborative creativity we're talking about, okay? This one is more in the category of true integration. Dario Robleto, a friend of mine, he has an exhibit now going on in the National Gallery, working with sound archaeologist Patrick Fester, retrieved actual sound from 19th century Pulse recordings. This was way before people could anticipate that you could extract sound from these recordings. Now the word recording immediately implies that you can play it back. But these were recording pulse, brain, sometimes people had accidents, part of the brain was exposed. And this required artistic vision, deep understanding of history or historical technology, and rigorous scientific method. You cannot separate the artist from the scientist, from the technologist in this work. This is another one a little bit earlier. Random International, Rain Room, shows what is possible today. I mean, they had these shows starting in London, but they had it in LA. Visitors walk through actual rain without getting wet because there are sensors that detect where people are, floor, ceiling. The people become performers in this technological artistic experience. The group represents a new model. You cannot separate the artists from the technologists. They are not collaborating across domains. They are creating a new hybrid domain. Now, what about AI? Here is my historical present for AI. Okay? When photography emerged, many people in the art world recoiled. Baudelaire was not a painter, but there were people on the visual art side. Baudelaire was a poet. Call it art's most mortal enemy. Photography was art's most mortal enemy. Maybe sounds familiar to some sides of the debate on current AI, but Man Ray an American who made his home in Paris, embraced photography in the 1920s, created extraordinary work. One of his photographs was recently sold for about 12 million. Photography did not kill painting. It became a new art form. The question is, will AI follow the same path from threat to creative partner? Here is an example of cross-domains breakthrough, okay? Origami existed for 500 years, possibly for much longer, okay? At some point, mathematicians codified the foldings, and at some point after that, engineers got interested, and now we have a whole field called origami engineering. The result is that you can have packaging, architecture, robotics, aerospace, solar panels that fold for transport and then unfold to a tennis court size, something unthinkable in 1950 or so, but routine today. But here is the key question. What could have generated this merger 50 years ago? In here you have origami, but you also have something at the bottom left. You have an example of an exhibit by an artist in Latvia, sculptures. They don't look at the sculptures, Michelangelo, plaster, marble. These are examples of tensegrity. And tensegrity and origami are coming together. I'm putting their work from my friend Glausio Paulino in Princeton. The key thing in there, tensegrity has been since 1920 out there for us to grab and use. Origami for 500 years. The question is, what kind of questions could have produced these kind of outcomes and answers? Everything that you see in this slide, okay? This is the collaboration sweet spot. Bad questions embed the answers. The question, find applications of origami in engineering. If you ask that question, you already know the answer. It already suggests a connection. A better question, probably not an obvious one, would have been, what about if we treated space deployment issues as folding problems? Again, the answer is hinted in there. The human contribution really is asking questions that may violate current assumptions. AI's contribution will be to explore the vast possibility of spaces that open up. Lots of stuff here. I'm putting what AI can do now. While it's not creative in the human sense, it excels where scale, speed, and systematic recombination matter. AI is fantastic in combinatorial creativity, I would say. But the 5 domains that stand out are combinatorial creativity, putting two things together, pattern recognition and prediction, optimization and search. I would say personalization, adaptation, I will put that last, but automation and repetitive cognitive tasks is important. So what is that one should avoid when talking about AI? And in here, is what I call avoiding the Anadol problem. Refik Anadol is a young Turkish actor, artist, and his work is visually mesmerizing. I won't deny that. He was given access to the entire collection of the MoMA, the Museum of Modern Art in New York, digitally, and he fed this into some algorithms. And this is what was at the entrance of the MoMA, a 24-foot high screen. He had a team of 15 people in his studio working on this. But then the problem is that he started anthropomorphizing the ideas, the things that came out from the algorithm, attributing human characteristics to the algorithm itself. The healing power, what is the machine dreaming when it sees modern, all the MoMA's art, giving making pronouncements about alternate understanding of modern art. My question is, what would have changed if instead of the MoMA's collection, he had been fed the San Francisco Modern Art Museum collection? The question reveals sort of conceptual shallowness. Now, if you think that this is hard, this is what the art critic for New York Magazine said, said unsupervised, that was the title of the work, is a crowd-pleasing, like-generating mediocrity. He went even further. The whole thing looks like a massive techno-lava lamp. It's like looking at a $500,000 price, more than $500,000, screensaver. So asking questions is important, and we should not avoid moving things out of bound, because instead of advancing the objectives, you put them backwards. Now, Picasso in 1968, the prehistory in computer years, he said actually this. He said, computers are useless. They can only give you answers. But the truth is that this is still valid. Questions are essentially for breakthrough creativity. Today's AI is incredibly sophisticated at providing answers, but still need humans to ask the breakthrough questions. Perhaps asking good questions is the essence of creativity. Let me give you one example. Could AI have invented cubism? I put this to exemplify the fundamental challenge of pattern breaking. Every single painting prior to 1900, the training data was representational. No statistical analysis or representational art could have anticipated the abandonment of representation itself. What Braque, Picasso, Kandinsky. So breakthroughs require abandoning things that are embedded in the prior data, prior assumptions. Another example, let's say you're an architect, you have commissions of designing amazing, you have the possibility of designing big spaces, atriums in hotels or buildings. You have access to every building ever built prior to 1960. Could one of the ideas about the atrium of these new spaces have produced what John Portman did in the mid-70s? By the way, John Portman had the advantage that besides being an architect, he was also a developer, so he had more complete freedom. And this is what Portman did. He freed the elevators from the confines of the building. Okay, that was a break with example. So I'm hedging my bets in here, putting the word yet in parentheses. What AI cannot yet do is the limits of training on history. So no analysis of pre-1900 art could have predicted abstraction and cubism. No analysis of pre-1900 physics could have predicted relativity or quantum mechanics. Every piece of training data contains implicit assumptions that break with had to abandon. So what is that AI can do? It's listed in this slide, okay? AI, in my view, will become a normal technology, will help us in language translation in between domains, will help us recognize patterns, maybe connections about vast knowledge of knowledge contained in the domains, rapid iteration, and combine insights from multiple fields simultaneously. But they need, in my view, still humans in the loop, some of them being the connectors between domains, people who are understand how others think. So the answer is, could AI be the tool that makes Holtzman's 1950s vision achievable? We're starting to see genuine AI collaboration models emerging. Not AI as a tool, but as a thinking partner. Humans identify which assumptions to question, and AI can explore what happens when you're abandoned. Humans provide creative interpretation of patterns that AI may discover across domains. So my view is that we need a question asking renaissance. We need to get better at crafting questions that unlock creative potential, that identify the varied assumptions that limit our thinking. The AI age demands this renaissance in human questioning abilities. Is what I would call our capacity for productive confusion, which at the moment is not easily replaceable. The ability to be really puzzled by what everyone else takes for granted. At least for now, it seems irreplaceable. Or the ability to question ideas that everybody has implicitly assumed in some domain and no one has ever tried to revise. So we are moving from a model of individual creative genius to collaborative creative networks. The goal isn't just to create amazing individual works, but to develop people and organizations which expand thinking spaces that can catalyze innovation across multiple domains. I believe that the opportunity is now better than it has ever been. So our path forward combines lessons from history with tools from today. Want to capture this in terms of examples that we saw there. We need the process focus of 9 evenings, the meeting between Bell Labs and artists, the openness of artists that embrace photography, the cross-domain thinking that created origami engineering, and conceptual rigor to avoid using impressive tools exceed our conceptual rigor, and endowing them with human characteristics, for example, or promises that are so hard to get. Like, for example, AI in drug discovery has not lived so far up to expectations. But the key to this is creative fluidity across domains will be essentially for going forward. And this is what I call in individuals nexus thinking. So we began with the mystery of how something comes out of nothing, the essence of creativity across all domains. AI doesn't solve the mystery, but it gives us unprecedented partners in exploring it. AI is a powerful collaborator, humans providing breakthrough questions and creative interpretation, working together across traditional domain boundaries. This isn't the end of human creativity. It's probably the beginning of a new chapter that could dwarf anything that we have seen before. So that's it. Thank you.
Thank you so much. I will now introduce our next session, which will be the roundtable discussion.
I think it's mine. Hi, I'm Lisa Marginelli. I'm the moderator for this section. I'm very delighted. Thank you very much for inviting me to this. I am the editor-in-chief of the National Academy of Sciences and ASU publication Issues in Science and Technology. And I am going to jump in and start asking some questions here. So before that, I just want to say, if you would like to ask a question, we have lots of times for audience questions. So you will see that at the bottom of your screen, there is a question mark inside a little bubble, and that is called the Q&A function. Please click that open and type your question in, and I will work to integrate your question into the discussion. Thank you to the panelists. This has been a very interesting conversation. It's mentioned, well, if there was a game here, Maslow's need pyramid, Vannevar Bush, Burning Man, productive confusion, lava lamps, my favorite things. So what I wanted to start with is that, it's interesting in this conversation as an outsider to the engineering conversation to hear many people emphasizing the very special role of engineers in the deployment of AI in society. So Dr. Liu said that responsibility rests on the shoulders of engineers. Marian described AI as a force of nature, the sort of thing that engineers are comfortable moderating or dealing with. Yanis mentioned that AI represents a phase transition or a singularity. So my first question is returning to the implicit sort of setup in Yanis's presentation about the 2005 project from the National Academy of Engineering about what the engineer of 2020 should look like. What kinds of skills should they have? And I wanted to ask you to just go around the group and ask you, what do you think the engineer of 2050 needs to have to hold this project on their shoulders? How do they become the human in the loop? What are their what characteristics are needed? Marian, please go.
Yes, I think I really resonated with Giannis's depiction of the programs that they have at USC, where trust is so fundamental and the character of the engineer is so fundamental. That I think is because this is going so fast and so quickly, and it's moving into production, and people are actually using it, and it's not, what we would call 100% reliable. We don't know really how to interpret a lot of what's going on quite yet. It's a black box, even to the engineers that have created it. That, ironically, I think that one of the most important characteristics of the engineer in the future is going to be the ability to understand how important it is to their job is to humanity. And they don't have that, sense right now. Not many of us do. But to be able to understand the principles of trust and maybe more international norms about what's right and wrong, and develop a certain sense of discretion and judgment when building things. And you can do that in a formulaic way by constantly testing or have evaluations done. But I think the other side of trust can be a little skepticism. So I think a healthy amount of skepticism so that these systems can be built with trust is very important. And I think it also gets to the point that Julio was making, is that the need to collaborate and do teamwork across many fields is what's really going to bring, I think, AI into this tremendous force that it's destined to be.
These are both interesting soft skills, what might be called soft skills. Yanis?
Yeah, I like to expand a little bit on Marian's point here. I think that we definitely make sure that our engineering students do not relegate knowledge and domain knowledge to AI. I think it will be a major mistake if we do that, because then we're not going to be able to have the expertise, this sort of human in the loop expertise that is needed. And so it is fundamental that we make sure that what we do, we keep producing this important knowledge for the future. The thing that I wanted to mention a little bit about this character idea is that, there is this trustworthy AI initiative that NSF had for a while. I'm not sure exactly where it's going nowadays. And I want to make a sort of bring here an analogy about character. And the question is that, you're lucky or maybe unlucky that I am Greek, because the word character is a Greek word. And so comes from the word harazo, which means I etch. So ideally, Character means there's some etching that's going on. You have an etched thing in yourself. And software, in many ways, is an etching thing, right? So we do etch into machines some sort of software. So whether we want it or not, we do etch character, if you wish, into a machine, and so doing it right, I think, is an important thing. So it's sort of I can see that these two are going together in many different ways. At the same time, I wanted to mention this interdisciplinarity that has to be for sure, and convergence that's happening across the board, given the fact that AI relies on data only, and it doesn't really matter whether the data comes from measuring your health status to measuring the status of the forest. I know Julio talked about Anadol. I got to meet him because he's here in Los Angeles, and he wanted to actually come up with some ideas about how the city and the forests react and sort of represent this in an interesting way. But the collaboration with other entities, AI allows this collaboration with other entities in a very easy way. And this actually benefits our students also to be interdisciplinary in many different ways. I just wanted to, so for example, in the area of arts, many schools have strong arts programs, and the partnership with engineering and technology is becoming bigger and bigger in many ways as well. So I sort of second what Julio was talking about this as well.
So for projecting that forward to 2050, there's a need to be able, there's a character and a sort of, but also you're saying that the character needs to be etched into the machines themselves?
I think that it is done intuitively, not intuitively, but the way we create anything that we create, because it has sort of this etching aspect to it. Essentially, it is by definition has a character to it in some sense.
Okay.
I'll give you and the way we train things. So I happen to be the editor-in-chief of a PNAS journal called PNAS Nexus, and we get all kinds of interesting papers to review. There was a very interesting paper that I just saw recently. I like to make sure I simply state that this is about how a if you train an AI based on a previous AI, the new AI acquires the characteristics of the previous AI. It's kind of funny. It's almost like, you have a child that is trained by their parents, and then the child gets the attributes, the characteristics of that. So in many ways, there's this anthropomorphism is in some sense that is happening between LLMs in some sense, which I find to be fascinating in some way, and probably maybe there will be a new discipline coming in, understanding how LLMs interact with each other and what kind of social interactions they have. I mean, it's not out of the question that we're going to be going into these directions in a significant way in the future, particularly when you get embodied AI and then you start talking about robots and things of that type.
So I just want to push this towards 2050 and for all of you. But what you're saying is that there's going to need to be sort of anthropologists of AI interactions.
No question.
And that the engineers are going to have that, to be able to have that kind of lens. Megan, you have your hand up.
Hi, yeah. I was just going to add in, I think where Giannis, earlier you were all talking about the collaboration itself and how we think about where the human role is and, where the AI role is. It's an interesting study out of the MIT Media Lab called Your Brain on ChatGPT. So just put the link in, but just looking at different ways we use things. And it's very clear that there's some destructive learning ways for students to be using this stuff. And there's some useful ways and really accelerative ways. And so one of the things I think a lot about is how do we take on whole problems as opposed to part of the problem and really think about, much like nuclear power, let's say nuclear fission, we have done a lot of work on the development of generating the power, mining, etc. We haven't done the same level of work on dealing with the waste, on dealing with the injury to people who especially live near these mines, or the transport goes through. And I think about, you know, people like Vannevar Bush, who led so much engineering for the United States, and his main kind of lieutenant assistant, Carol Wilson, who was the Atomic Energy Commission general manager, the first one. You know, he eventually came to the point where he's like, we're not willing to be safe enough. Even though he was one of the proponents of all this work, he really moved away from nuclear power. I bring that up because I hope for us as humanity that we're willing to run at the, you know, as engineers, we take on hard problems. And so if you, again, it's another aperture, widen the aperture big enough to see what the good and bad is. And as we find it, I think one of the answers to your earlier question about, you know, what do we need most? What do young people need most? They need colleagues. They need colleagues, and they need people from lots of different disciplines. They need all different age groups, all different people. You know, because the reality of AI is extraordinary and a little bit depressing or terrifying. You know, I'll give you an example of a terrifying thing. I might just share a screen. This is somebody looking at generating off of prompts the truth of ghost workers. You know, people really who are trainers of AIs, people who sit all night boxing, teaching the AI what things are, people who have to clean you know, porn and stuff that really is true. You know, and so I feel like, you know, the empty chair, the person who gave up, the person who is making no money, while others get billions. And I think it's worth noting the existence of the whole problem right now and working together. You know, what kind of society do we want people to have those kinds of jobs? Why are we doing this? Or at the minimum, can we be more aware with our engineering students of what's existing for some people around the world? What's the plan for when we are replacing jobs? Like can we run at that engineering problem, which is a multidisciplinary problem? It's not just an engineering problem. You know, you can see that corporations will want to reduce costs. So there's this jobs center. So let's get rid of some of those. You know, it's going to be an interesting future if we can get there, but it's also a dangerous future if we don't bother to kind of keep our lens open about what the challenges and opportunities are and work together and really welcome the 8 billion colleagues in a way, rather than some are doing this and some are not. And that's the exciting thing for us as engineering leaders and the engineering deans on this call, and what we can present to students. And so huge opportunity. And just the last thing I'll add is I put up that image of the challenges of automation together with the mitigation strategies, because I found that a lot of people don't work on the mitigation strategies, even though those are a known thing in the literature. Let's run at it. You know, let's take the whole problem and work on it.
I'm going to summarize. I'm going to go to you, Julio, in just a second.
Yeah.
Just to summarize briefly what you just said is that it's not in 2050, it's not a single human in the loop, or even a single engineer in the loop, or even an engineer alone in the loop, but 8 billion people in the loop, essentially. We're moving towards an incredibly different conception of how this particular technology interacts with us, and which suggests sort of a level of social science and human consideration in addition to this, which seems like a good note to go to Julio.
Yeah, I'm by nature optimistic, but I don't think we are creating enough people with degrees in engineering who have the ability to seamlessly connect with people in different areas. Okay, Karl Popper is the famous Austrian philosopher of science, talk about clock problems and cloud problems. Okay, a clock problem is something that may be really difficult, like fusion, but at some point you can solve it. A cloud problem is amorphous, shapeless, changeable. You don't solve, I don't know, congestion in Chicago forever. I think most of the people that we produce are really people who are really trained mostly to solve clock problems. the problem is that at this moment in society, if you look at the entire web landscape, okay, as a sort of evolutionary landscape, okay? I have one of my colleagues in here, a former CEO, who's a professor in Kellogg, a colleague, whose field is values-based leadership, creating people who have good values. But the truth is, you start looking at CEOs from the top, okay? Steve Jobs was a genius, a vision, communication, execution. I wouldn't say he was someone grounded on values-based leadership. If you look at the landscape that produces people who, there's some fluctuation in there that creates some competitive advantage, and then it gets amplified, and the fitness evaluation produces more on these people. The landscape now produces people who, probably the most adapted one, are influencers, completely useless people, but the landscape produces them. You can look at this framework and look at the political landscape. I don't know what on earth can one do to change the landscape to produce more people with values based on ethics, just being a good person. It's really not something that can be fixed immediately, but that's the landscape in which we all operate.
Thank you. I want to return to the question that you're raising in a second, but let's go ahead. And Wanda, do you have sort of thoughts about what the engineer of 2050s, we're rapidly developing quite the cloud problem on that engineer of 2050. And I wonder, Wanda, do you have some thoughts?
I do. I think that in 25 years, engineers will be very different from engineers of today. And I'll just take you guys on a journey. I think as I look as I look across this field, I think a number of you remember the days when you had to use a slide rule or memorize log tables in order to do calculations, or you had a class in drafting. And obviously that is no longer part of the educational requirements for engineers because tools do things differently. And I think AI in 25 years will evolve to be a tool and an opportunity for folks to free up time to be more creative and more collaborative and follow a number of the things that we've already discussed. So that engineer will have to have a bit more of exposure to critical thinking. They will have to be amazing at being able to ask those critical questions that will drive solutions, because there will be tools that will do a bit of the rote engineering scope. And to Giannis's point, that rote scope needs to be deeply understood. So deep thinking, deep understanding of the fundamentals of engineering physics will, I think, return to engineering education. And I think that we'll have a generalist capability that we will require of engineers to not just be capable of understanding other engineering disciplines, but pretty much the world as Megan's described it, of what engineers will be required to contribute to solving humanity's problems. So it'll be a different person, and it will have to be, I think, generally more inclusive and accepting of new ideas, because those turbulent questions that are going to be required in order to reach more significant solutions will be what we'll call an engineer to accomplish and to do.
Did any of you want to follow up on that? All right. So
just agreeing with what Wanda said.
Yeah,
I think that's really. Lisa,
yeah.
I have one little thing to add, which is I have a son who's studying engineering, and he says he thinks it's strange that he has all these engineering classes and humanities classes, but that the humanities students don't have engineering classes. And I think that they'll have a STEM, one STEM or one math or whatever. And I think that is yet another opportunity where maybe we don't have to have so much distinction on who's who, as maybe this broadens participation in a good way. can we help people take action on the things of interest to them? And that action could look like a journalism move, a essay, a policy move, an engineering move. And that if AI is assisting with that, as well as we're using the network to interconnect more humans to be able to work together across interests, in a lot of things that I was showing about network effects, that's a real opportunity that I think just reinforces what Wanda was just saying.
And to pile on to that, Megan, I think all of us as engineers have used artificial intelligence probably for the last 20, 30 years. But what everybody woke up to was open AI, access to it for the general population, for the world overall. And to Megan's point, I think that there's going to be a little bit of engineer in everyone else as they start to understand the real opportunity that AI brings. And then again, that's going to shift our expectations of what engineering can do.
I think that's another thing to the 8 billion people in the loop is a little engineer in everyone, in this sort of blurring of some of the boundaries, which, I think it's Robert Louis Stevenson's parents were builders of lighthouses. So we had this mixture of, there was at another time this incredible mixture of engineering and artistry at the same time. I want to talk a little bit about how, jumping sort of into Julio's question about how do we address some of the challenges of AI. What has been suggested so far in this conversation has been really focused on the individual engineers. So trust, character and purpose, the ring that the Canadian engineers wear, which is something that I love. But is there sort of a need for a bigger sense of governance? I can keep going if you, Yanis?
Well, it's almost inevitable that there will be something of this effect because the technology can be extremely powerful. And so as a result of this, at some point, policy issues have to be articulated. I know politically this is an interesting topic, but because this also involves competition between countries and so on and so forth. But I mean, if you look at the potential of misuse of technology with respect to from misinformation to many other things, at some point we have to have an arbiter of this, and so some policy has to be included somewhere. I don't believe in the history of the world technology has been left unregulated at some point, and I don't see why this will be different with AI. I know there is this sort of a AI race about how we can compete with it, not compete, how we move on. To this effect, I read this article by Tom Friedman at the New York Times the other day, which actually suggested that countries that potentially want to have a supremacy in AI between, let's for instance, China and the U.S. Actually collaborate with each other because of the potential effect that this technology may actually supersede the intentions that either country can have. And so in some way to come to a convergence of sort of a human efforts in this area as well. So I believe that policy will be there sooner or later at some point.
Okay, Marianne?
Yeah, I agree that overall governance is needed. It really is a question of who should provide it. In Europe, it's much more active right now than it is in the United States. It was within the United States for a while under a different administration, but it's not even clear that it's a governmental duty versus a consortium of governments and corporations and universities, because you can put what we were seeing happening is there were stated proposed policy changes and government changes or governance changes, that weren't implementable. And so it's so important, I think, to have, these different segments of society working on AI come together to create some type of policy framework. And there have been, various attempts at doing that, but, maybe as an AE, we can really foster that.
Well, I want to focus this question just a little bit more. I mean, we often talk about the individual character of the engineers as something that can be taught, sort of character and purpose can be taught in schooling, and that will help them determine what they're doing with AI. AI is huge, it's collaborative, it involves data sets, it learns from other data sets, it learns from other AIs. Like, the question is sort of, how is focusing on the individual enough? I'm going to give you a little framing. I spent 10 years following scientists who studied termites. And one of the things about termites is that all the termites build these gigantic mounds. So, several million termites will build an enormous mound, like 15 feet high, with tiny, tiny microscopic bunches, not microscopic, little tiny, tiny balls of dirt that they put down in their mouth. Every termite is doing what they're supposed to do. They're running towards the hole, they're running towards the place, they're putting down their ball of dirt, they're doing exactly what they're supposed to do. And then a mound emerges. Well, this is also what happens with AI, is that all of us do what we're supposed to do and we all follow the rules. And a mound emerges and whoa, it does something else in the landscape than the individual actions that we took were. So I guess what I'm asking is, and this relates to the question of the engineering ring, and sort of, is there a way that the group, the community of engineers, can engender kind of new thinking about how engineers take part in that, in the assurance and as holding that relationship to society on their shoulders? Julio, and then Megan.
Yeah, so you touch on something that is one of my passions, emergence and complex systems. Okay? I think that the policies will emerge. The real issue is that the outsourcing of a competency. If one starts, and this goes at the individual level, starts outsourcing part of the thinking, that's not good. Yanis alluded to this, that maybe students will have to have final oral presentations or something like that to defend every part of things that they were provided as part of the thinking. But that, I don't think, is something that can be solved with policies. This is, AI will be there, regulated or not, people will use it. And I have been, by the way, I created a program, a fully blended program in between the business school and engineering about 6 years ago. So I started thinking about this probably 9 years ago, mostly because I have one of my faculty who is still part of the old AI thing, symbolic thing, in which he was telling me what is coming now is so brute force, is not elegant. So I started paying attention in conversations, and we created this because, let's face it, MBAs need this. The program has been functioning for about 6 years. But the question is, to what extent AI will start replacing a human competency? If that happens, I think we elevate the people at the top, but I do not know what will happen at people who are more at the bottom of the pyramid there.
Thank you. Megan?
Yeah, and by the way, I'm traveling. My internet seems slightly unstable in this location, but hopefully that's okay. I was going to share a couple things. One is that early on, the Stanford team started to do something called the AI Index. Just how do you measure our progress, and running at trying to do that. And I shared that I and another colleague were writers for the expert panel area. And one of the things we really focused in on was existing law. that we really do have, the Universal Declaration of Human Rights. We have a lot of things that exist in law. And so to the extent that a technologist and engineers are being taught law and encouraged to follow the law, there's a character in Silicon Valley called product counsel. It's a lawyer who's usually embedded, with an engineering team as they build. And they're teaching them, for example, we were looking at, when I worked at Google book search, what amount is fair use to show in order to make all books in the world searchable, but in what's not. And so having a legal colleague in the mix is really important. And making sure engineers are thinking about that. I was at a conference recently with a legal person who had an AI, and the person said, look to your left, look to your right. One of you will be breaking the law in the next year or two. Just trying to get people to notice that we're already in this new frontier. And so how do we support people and our engineering students especially, as well as practicing engineers, to stay within those limits? Now, I can also say that, ships are wonderful and ships are used for amazing things by lots of people, but there's also pirates and people who would do bad. So that's also, we need laws and regulations to also mitigate and be able to hold people accountable as well. So these are some of the hardest problems of our times. And the thing that I've found is the most helpful on these hard problems is when we have a very diverse set of people working together in terms of their background, and you're doing it in an open, transparent way, so that you can, like we did those AI town halls, you can get a lot more eyes on, and you can see more where in what you're doing or where the opportunities are. This is a multidisciplinary team sport. And if you think of like an orchestra, a lot of times the policy folks have technical people over in another building. If it was an orchestra playing the brass and here's the strings over, and vice versa, will go, and the technologists have other people who are they're not in the room together. And it's one of the most urgent things we could do. And so that would make me think the best practice we could do in our educational institutions is creating those kinds of lab experiences, which I know many are doing that, the way that Harvard, others, the business schools do.
Thank you, Megan. Wanda, did you, Yanis, I see you have your hand up. Wanda, did you want to come in here, or shall I go to Yanis?
Oh, since I have the opportunity, I'll share a couple of thoughts. I think that heavy policy to control an emerging field is unfortunate. I do expect each of the disciplines that use AI and other similar emerging technologies will probably have controls to make sure that termite mounds are safely built, and other structures. And I'm hoping that that is the control mechanism that we rely upon, because I do think that putting constraints on an emerging capability at a broad level could have major negative impacts. I do like the focus on ethics and capability at the individual level being our focus at this point. I've heard Megan, for example, talk about the fact that ethics is typically a side hustle. It's something that is not necessarily embedded or imbued in engineers from day one. I think that because of the strength of this tool and its intertwining with society and opportunity requires more of an engineer, that hopefully that ends up being more of the curricula that we engage our engineering communities to learn and embrace. But as far as larger policy goes for something like AI, I think there should be guidelines. There should be some controls perhaps on the training data sets, but I would hope that we wouldn't constrain things too much at this point.
Yanis?
Yeah, I just want to make 2 points here. One is that back in 2023, Eric Schmidt and Mustafa Suleyman sort of put a manifesto forward about safety in the sense of the same way by which the Intergovernment Climate Panel was supposed to be. And they call it Intergovernment panel on AI safety, I believe. I don't believe this idea took much root because obviously nothing moved forward as a result. I mean, after that, but you know, they were making some very interesting points about you know, this. I understand fully, and I think you know, a nascent technology, well, nascent that moves very fast. You know, making sure that you allow it to grow, but in a way that it is actually beneficial. It's a very subtle thing, and it has to be done very carefully. And I agree with Wanda in that respect as well. The you know, getting our students to understand you know, the impact of this is becoming more and more. I see this more and more in our students. The younger generation understands impact of that, and they are interested in understanding the impacts and how far they're going. At the same time, you know, the opportunities for developing innovation and startups in this area are extraordinary nowadays, and there will be even more in the area of robotics and embodied intelligence when you create other things as well. And I think there is a tremendous, I think we live in a tremendous era with respect to, if you look at the investments that are made that are extraordinary. This obviously tells you two things: that the technology is moving very fast, and its impact will be also, the expectation of the impact is going to be significant. So I think we live in a very interesting era. I wouldn't go all the way to 2050, Lisa. I think I will be more modest and say maybe 2035. If we can predict until then, who knows? I think these are happening incrementally very, very fast.
So I'm going to interject just a little bit of an outsider's perspective here, and partially because I'm reading a book by Deborah Rosenfeld from the 80s about people who were working in bomb development at Los Alamos. And I think one of the things that's an issue for a profession is if some sort of accident that's terrible does happen, it can really make it very difficult to be a member of the profession. And it's worth, as engineering leaders, I think, thinking through how do you help people start to navigate what, you know, engineers have been loved for making bridges and tunnels and sewage systems that work and things like that. And when they are also working, and I think we're using computer engineering and engineering and AI, the sort of computer science aspect, we're overlapping that with engineering to follow up on one of the questions that was asked. But, you know, we do have a bunch of questions in the chat about, it's a fair question, what happens if we're not effective in training engineers with good ethics programs, and how can it be integrated more fully. But I think it also is some sort of, there's an element of the training has to do with insulation, of helping people understand that they're doing the right thing, and how they can do the right thing is going to become important as a number of wrong things become obvious. But I want to move on to all the good stuff. So the next question I had was, you know,
Just before you move on, I just want to say, in these areas of wrongs, there already are wrongs. There are already lots of harms. People have lost jobs. People have had promotions. People have not been hired. People's resume has been routed wrong. There are many, you know, dozens of people who've been taken to jail for face recognition misidentification. So we are with that already. And so the question, I think, for the whole field is to be transparent and acknowledging, and then do things about it. You know, there are problems with lots of technologies, you know, and where we can be more vigilant about noticing the harm and then doing so. That's why I really encourage people to read or listen to Kathy O'Neill, in I think 2018 came out with Weapons of Math Destruction. And she was just sharing very specific FOIA requests that she made to algorithm, you know, owners who, yeah, perfect. So, and she's a fabulous engineer, you know, so it's really an engineer's approach to what's really happening? Let me look. And you could see some of the promotion systems were just noise. It was bad engineering. It was the Ottawa Bridge right there. And so how can we use that stuff actually in our curriculums and like embed it in to help people learn from the bridges that have fallen down so we don't do that again, or the Titanic rivets, or whatever it is that we want to not do again. And notice that it's already well with us. I think because certain communities are experiencing it more than other communities. Some people are even not aware that the challenges exist. But they are well with us for more than a decade at this point.
Thank you, Megan. Julio.
Now, let me give you one example of a possible cross-domain thing that has to do with ethics, okay? I was known in here for whole brain engineering that blended art, technology, science, and a whole bunch of things. But many, many years ago, before I became faculty in the business school, I decided to take one of the executive courses in which there were people with 15 years of operational experience. And one of the things, I was the only academic in there. And one of the things that I was impressed by was the value of role-playing in case studies. So for example, there was a case of if a CEO should be deposed because it had done the thing. Some people play the board, some people play the media, people from foreign investors, a whole bunch of things. So one thing that I wanted to do here was magnify this to the level of the university. And we have a fantastic school of theater. And maybe now we could do it. I tried to persuade everything that I did started with a bilateral connection, me convincing the dean of Medill or the dean of Kellogg. I tried to convince the dean of School of Communication that wouldn't it be good if we develop case studies and for some of the crucial roles, use people from theater to play the role. I have seen how people get into, this is half a day that you get completely immersed in one side of the things. And I was never able to pull it off, okay? And I thought, maybe the people from theater will learn something about technology and science. Maybe the people from engineering will learn something about other fields, because you can imagine you could bring everybody into this. Anthropology, sociology, psychology, neuroscience, everything. I think someone should do this because this is the closest thing that you have to approximate in some ethical dilemma without someone giving you a lecture about it. It's just been placed in there, you place a role, you have to defend your role. But it's crucial that we have something of this going on in the education of people in engineering.
Thank you. Alternatively, maybe we can have the engineers taking part in Shakespearean plays and then reflecting that into their own work.
Absolutely.
So I wanted to go on to sort of a broader question on education. And this is kind of paraphrasing Megan's question about, can AI help expand who is an engineer and what is an engineering problem? And I wanted to see if you had some thoughts about using AI in engineering education.
I think I can address the second part.
Sure.
Which is your second, the part of your second part of your question. Not only we have to include it, it is happening in many different ways. As I mentioned, it is happening both at the course level, let's say undergraduates, because the ability of these LLMs to be able to provide to you answers and also act as an equivalent of ATA, I think, are there. So the question is, how do you do this right? How do you, and I think this is going to change to a large degree what it means to have a teaching assistant in, let's say, an undergraduate class. Now, I was discussing with one of our faculty the other day about that, and what the most interesting contribution that, let's say, a teaching assistant can make in a class that it is not done by AI is in a hands-on class, laboratories, experiential type of things, in which case you need sort of the expertise that right now AI cannot provide, although it is not out of the question that in the future robotics will come in and provide a little bit of that as well. I think that we will be able to have intelligent machines that can help you in that respect as well. But it is here, and it is addressed at different places, with different means. I think the strategy right now in universities like mine is let the faculty member make it their own decision on how to use AI. So there is no prescriptive way of saying, well, AI has to be used this, and that. And so everyone is using their own method. At the same time, in the School of Education, with which we partner, there are the development of interesting tools that actually can help the learning process, with the goal to make sure that you get this critical thinking effort as well. So use of AI in undergraduate courses and majors is happening as we speak, as I mentioned, and also understanding of our students what it means, how does AI work? So demystifying what it means by AI, it's an important part as well for people to understand what exactly is happening there, because it is important for someone to have this technical knowledge as we move forward, so that we can demystify it. Now, at the graduate level, including, for example, at the PhD level, the research level, AI will accelerate discovery because it can help you do all kinds of things. And then this may compress, I'm just speculating here, the time it will take for some PhD students to earn a PhD degree. In the past, it took 5-6 years, you get a PhD, you work on your subject and so on and so forth. It is not out of the question that this may actually condense, or we will change the way by which we evaluate what it means to have a doctorate, let's say, in a particular field. I anticipate that this is going to change things as well. Finally, one thing that we see, a trend that is sort of developing, is that, the previous era, let's say the era of technology that the engineer of 2020 addressed, was very much driven by an extraordinary call for more people to do STEM disciplines. I think that the AI era may actually change that. In other words, that students may say, well, I have an AI tool, maybe I don't need to understand STEM. Maybe I can use it for business or other things as well. So there may be a switch of interest that we don't see it yet, but we may see it in the future, particularly in computer science, which was, an area in which was sort of the passport for great success. And I'm not sure that I think that there are a number of articles out there that sort of paint an image that maybe the future is not going to be as necessary. There will be no such a great demand as before, and I think that's something that most of the schools are looking for to see exactly where it's going. As you know, AI has been in the area of software engineering has made tremendous progress, and so that's actually a field that's impacted significantly by AI. So there's all these elements out there.
Thank you for that. That's an excellent sort of summary of kind of where we are now and in the near future. And I think that there is this question that Megan opened up and that was sort of underlying the premise of this whole meeting was sort of, is there a possibility of transforming engineering education, of who becomes an engineer, of opening it up to people who are in rural areas, opening it up to people who may have disabilities who wouldn't be able to go to traditional engineering labs or may be able to use different faculties to do things. In other words, accessibility, and as you mentioned, this sort of expanding access to teachers for any person with any level of interest. Megan, I think that might be what
I think what an answer is related also to what you just brought up, which is, yeah, I really believe this is one of the greatest opportunities that we have, is sort of broadening the participation on the design side and co-creation, especially with people with different interest areas in it. So it's both the people, but also the topic. One of the things we did this summer was we had an open call with all kinds of young people who were doing environmental justice, data science, storytelling, learning, but co-creating with other students from across the United States, just making these fabulous, learning coding, but really on behalf of environmental justice and story making about communities and data sets that they were concerned about. And a lot of times young people come into tech through robotics or through other topics. And so this was broadening tech's force so they could say, oh, I'm interested in this area, I come. So I think a lot of sandwiches that there's a really interesting emergent capability, which is doing it in sport. And so I put in the Justine Cassell-Mellon. She has for a long time had this idea of an avatar, an agent who's working with a bunch of second graders at a time. She has a group working with an avatar available. And so instead, the young people are learning with the AI supporting them. They can also notice strange things from the AI, right? So one critical opportunity is how do we have students get to do group things, and especially when we have varying skill levels, and also a little bit of, some young people are afraid of using AI, or they've been told it's cheating, and then other students are using it all day. And how do you get those 2 or 3 or 10 students actually in the same study group and cross-pollinating like a community practice and upgrading themselves as a guild? Huge opportunity there. And I have a colleague who, in her company, they have AI office hours, which is not someone helping you with your AI. It's all of them signing on and having fun. Like a couple hundred people sign on and just show cool things they found or something they're worried about that they noticed. Or it's really an open dialogue, and it's totally transformed this very high growth company. What a cool idea, right? Why wouldn't we just do that? So it's sort of interesting to think about office hours. Giannis, so you're just talking about the TA, right? Is the TA not just a one-on-one thing I have, but it's all of us coming together for office hours and exploring things in ways that leverage the tools. It can be very powerful.
I think that's interesting. That sort of goes to what Julio was talking about really asking questions that kind of break the frame. And the assumption with AI at the moment is that it's an individual alone with their phone or their computer or something like that. It's a very solitary, increasingly solitary, away from other people sort of pursuit, and kind of reframing that into a group collective thing with collective learning is really interesting. Mary.
Yeah, just to echo what Megan was saying, and also a bit that Giannis was talking about, I think the content is really important to draw people from that have felt uninterested, maybe felt even a little excluded from engineering or pursuing something in engineering, in that, it's such an age of innovation. And, there are projects I know going on at USC, but across the country in different industries or different technology companies about like homelessness, and how do you solve homelessness? How do you do better forecasting of fires and floods? And, how do you provide better maternal health? And we're using AI tools in all of those. And, it goes on and on and on, but these typically have been content areas that I believe like a lot of underserved people are interested in, as well as others, of course, but in particular, the ability to perhaps help other people and also, change society in some very meaningful way, I think has attracted more people into the field, which is good.
Yeah. So I want to switch unless anyone has a follow-up to that, I want to switch to some of the questions that came in from the audience. And we'll just do some kind of rapid answers. So we have a question about how do we engineer human agency into human AI problem solving? It looks like we are giving human agency in how we interact with machines. How do we does anybody have a quick answer? Yes, Yanis.
By human agency, we're talking about, we're not talking about LLMs here. We're talking about machines, like robotics and stuff.
They say human AI problem solving. How do we engineer human agency into human AI problem solving? It looks like we are giving human agency in how we interact with machines. What is the cost of this common behavior to human creativity and the engineering creativity specifically?
You mean how I see that it is the question that the way we train LLMs or machines, they make them acquire anthropomorphic, in some sense, kind of things.
I think that's one to answer.
Yeah, I think this is inevitable in many ways, because the more data you put in there and the more the machine is capable of adapting to this data, I don't think this can be limited. We see this already happening in many different ways. In many ways, in a deleterious way. You probably saw the fact that LLM sometimes are used as a psychiatrists. And I think there was an issue very recently in which facilitated the suicide of a person, which actually I think is horrible. And so this definitely is happening. And this is where I think maybe the policy issues that we discussed before need to come into play. For instance, in this particular case, I think the obvious solution was to make sure that an LLM of this type immediately notifies some sort of a human emergency, or that there is a potential issue here. But I think this is the place where I think this is a great dilemma for the future, and how we resolve that will require some sort of a very careful analysis and view of what is this sort of intertwining that I mentioned between technology and humanity. I think it's an open problem as far as I'm concerned.
Thank you. There is another question somewhat similar. In the age of fierce global competition for dominance in AI by different countries, how can one even imagine a thoughtful rules of engagement? Any takers? Going once, going twice? I'm going to say that if you don't imagine thoughtful rules of engagement, there won't be any. So you must absolutely, this is the responsibility of every human. Megan, I'm going to give this one to you.
Yeah, and I think that in some ways this is also prototyping, right? So learning as we go, we have to figure this out. We have to call these hard problems and figure out how to run at what the rules are going to be. There is a free-for-all going on, and everybody's doing their things, but there are laws. And so how do we maintain that legal side? We talked about it already a little bit with that concept of product counsel and other kinds of lawyers embedded with engineering teams. That would help a lot. There's always going to be, like I said, if there's ships, there's pirates, there's going to be people breaking laws, but that doesn't mean everyone has to do that. So I've seen so much, and we've all seen so much incredible prototyping going on. The Europeans, South Americans. If you aren't familiar with AI global policy work within the United States and different places, just go into one of the alums and ask some questions about it, or just search a little bit, and you'll find there's an extraordinary emergent body. And it's really hard work, just like the engineering of the tools themselves. But people are running at it. And when I see the best work is when there's, one of them is that the industrialist technologist is there, and the extremely knowledgeable lawyers, policymakers, but also a socio-tech person, which is a technical person who may not be in a corporation. They're more, there's people at high levels of capability there. And when you have that person, then when your industrialist might be saying, we're working on it, they can say, how are you working on it? And get specific into that. And then you can tease that apart, and the policymaker can hear that. And then together you might be able to figure out some rules of the road. I'm very much with my colleagues of not over-regulating. That's very a bad place to be. It quelches things, but there's some that's needed, and it's iterative. And so we have to work together with multidisciplinary approach.
Oops. Sorry, if Yanis, if you could make it quick, I want to get to one or two more questions before going to our wrap-up.
I would like to only add here the global nature of this. This is not, and it's also not in between two great powers or economic powers, but you do have places, for example, in the Middle East, Saudi Arabia, UAE, that develop tremendous ability in this area because of the fact that there is the ability for big data centers in those two countries. So this is not something that is only a limited conversation between two major powers, but I think it's a conversation that is essentially global. And I think that we should not ignore that.
And to build on what we talked about before, I mean, it will only become more global. I think this is a question sort of aimed at Julio. What opportunities exist for artists to collaborate with scientists in exploring and shaping the role of AI? And do you foresee these kinds of collaborations being built into educational settings or institutions?
Yes. So on one hand, some of the early things about AI and art were very naive. There were questions as to, can curators and art historians recognize this painting painted in the style of Matt Rothko from a real Matt Rothko? That's a really silly question about the ability of AI to create art. Mark Rothko happened. There is no room for a second Mark Rothko. An artist creates its own DNA. It cannot be a melange of everything created in the past that somehow emerges as art. Okay? An art has to break with constantly. Now, there are people, Julian Schnabel, for example, worked for a year with someone very much immersed on the AI guts of things, training AI to collaborate with him in producing new art in the style of Julian Schnabel. Okay, so I think that it will become, in some sense, a true collaborator. Okay, but at the moment, if someone comes with a counterexample, I will be great. AI is limited in the ability to break away from the data set that gets fed into it. So it cannot produce break with. Most of the things that you see as amazing things are really nice and clever. I'm impressed with Move 37 in Go, but that's really a silly example. So unless there are a way of breaking away from the training data in some way, that's why I put the word yet in there. The ability to create new art by itself, I don't think will happen, but I see artists collaborating with AI. And it's happening. I mean, I'm sorry for using Anadol as a sort of negative example based on sort of the comments that they made, the whole things, but it will be more and more. But at the moment, it all depends on the questions that you ask. And that's why I want to say that there has to be a renaissance in the ability of people asking questions, because AI is as good as the questions that it gets asked.
So that sets up my last question. This is just going to be kind of a lightning round here. You know, if you take everything that you're saying and we just say like, okay, let's say we get we know we're going to have this is going to be a mix of good and bad. But if we move to this like renaissance of questions, the role of the engineer is going to be profoundly different. And so if you were talking to your great-great-great-great-grandchildren, or whatever level they are, in 2045, about their majoring in engineering, because the universities still exist in the same form, but let's just presuppose everything. Okay, so they're at the end, they're majoring in engineering. What should their minor be? Should it be in origami? Should it be in Merce Cunningham's dance? Is it in Shakespeare? What is it? Is it in playing the ukulele? Is it in forming like big groups of people dancing together and playing together? Or what is it? Megan?
Okay, so two quick things. That's a Raspberry Pi. I don't happen to have an Arduino. First off, I hope every one of them, the young people, have already played with this in preschool. The Muskogee Creek tribe is doing robotics in Head Start, so I hope they're familiar just as much as playing with the ball, and they're doing all those things, and that all the disciplines are integrated. They're playing music, all those things. And then I would say I was really lucky to have a chance to be taught acoustics by Professor Bose of Bose and the speakers, and his main passion. So my headline would be, hopefully engineering, whatever their passion is. And the thing I would hope is that they hang out with people of lots of disciplines, so that they're multifaceted, but get to do what they focus on.
All right, I'm going to call on Marion first and then Yanis.
Thank you. So my desire would be to have people trained in social psychology. I was going to call it social engineering, but social psychology, so they understand the end user and the people that they're building things for, and they take that into account as they're building them. That has paid off, I can't tell you, enormously in my career, is to have that understanding. And most engineers are not thinking about the person actually using things. So especially in the area of AI, I think that's going to be incredibly important.
Thank you. Yanis?
So I used to have a sort of a exhortation. I called it hug the exponential. And hugging the exponential meant, just take the technology that just moves fast and hug it. So now I have to change that and call it hug the singularity. And so I think because that's where we are. It's important to notice that, to point out that there's a lot of disciplines have emerged over the years as a convergence of different disciplines. Take biomedical engineering. Biomedical engineering did not exist,
We only have one more
100
minute,
years.
Yanis, so if we could.
Yeah. So my expectation is that there will be new convergent areas that will be created, and that will involve engineering in different versions of that. I'm excited about the potential for this to happen, and this may include many of the other disciplines like that Julio was talking about, for example.
Fabulous, thank you. I'm going to go to Julio next, and then turn it over to Wanda to take us away.
So the opportunities, engineering as whole field embraces art, technology, science, okay? I have had tremendous advantage in bringing to what was conventional engineering, to bring in an artistic side and somewhat a humanistic side to the thing. So what is that you should focus on? Could be anything. There could be, in here, for example, we let people design their own majors in engineering. But the focus is on the timeless skills that engineering brings. Creativity, design, ability to think in terms of systems, interrelationships. Quantitative skills will never disappear. So the timeless skills is what is going to be permanent in the thing. Pick anything you want, but broaden yourself, include humanities, include some art, have a wide lens to look at the world.
Thank you very much. This has been a lovely conversation, and I want to hand it over to Wanda. You can take us away.
Well, thanks, Lisa. And thank you, Giannis, Megan, Julio, Marion. This has been a lot of fun. It's been a great dialogue. Thank you for your introductory presentations. I think that was very mind-opening in and of itself. So I'll say, please join me in a virtual round of applause. This has been fantastic. And live long and prosper. So
Yeah,
thank you. Oh, doubly. So I'll share a few of my key takeaways, and because I did learn quite a bit as part of the last few hours. I did take away that the successful attributes of engineers remain consistent. That they will continue, but there is a change that's on at the cusp, even though I don't know that it's truly been a change, but it's definitely something that we're talking about as we consider the opportunity to engage in the age of artificial intelligence. And it involves emphasizing purpose, character, and ethics in our emerging engineers. I learned new terms. Sustainable prosperity, which is the lens of an optimistic view of everything, which should be our guiding principles. So it's all things associated with our human future. It should drive our engineering endeavors. And again, I like the live long and prosper theme, Julio. I learned the term, well, it's not a new term, but we talked about collaborative creativity when science, technology, and art can work together, as opposed to, I guess, a vision I've had of science and technology serving art in many cases, or in my business, we support the visions of scientists and project engineers or principal engineers who have a principal investigators who have a vision of a new future where engineers somewhat support them. It's the collaboration that allows for us to have a word that I've not really used, break whiffs, which changes the vision of what's possible and pretty much allows those stepping stones that we associate with the growth of humanity to take place. I learned that you can describe everything with a formula, which which isn't surprising, but it's there. And that deep technical knowledge of artificial intelligence is necessary across all disciplines. We talked about engineering, but I think there's more. As we talked more disciplines, it seemed like that element is also going to be important for other folks going forward. Many right things are already in place and exist, and it would be a shame for us not to consider them. And having everyone involved in this combination of technology, artificial intelligence, and people is critical. So in conclusion, thanks to all of you for participating. Thanks to the NAE staff who made this possible, and thanks to our sponsor, the Alfred P. Sloan Foundation, who supported us and made this happen. So thanks to all of you, and have a great evening.